remember how to do this as we go through our stuff. When I was looking at some of the homeworks and things, when you guys are doing it, sometimes you guys have a tendency to skip things. Please don't skip things. Take your time to do the right things. Okay? There is no rush to get them. And unfortunately, there is no magic way that everything always works the same. But it's the idea that you know, by now you guys understand algebra. We've had lots and lots of algebra. It doesn't really change. But if I see this, excuse me, what's the first thing you're going to write down? Given. So 2x minus 1 equals 7, that would become your given. All right. What do you do next? You're on the right track. You're thinking subtract the negative, which is adding. Your add, what do we call that? Add, prop, equal. Simplify. Very good, very good. And then last but not least, and this one is solved. Very good. Solve versus simplify. Remember, solve, when we're talking about algebra, is the last thing when you say x equals something. And solve. Again, a lot of this stuff is very, very straightforward. Not a lot of craziness to it, especially the algebra. But today, it changes a little bit. Today, we change it up and we start talking about how does it work with what are called congruent figures? Okay? How's it going to work with what are called congruent figures? How do we write up a statement to get us to go into things? Okay? I thought you were going to pay me to do it. Well, I don't know. Maybe we can work something out. What is it, $2? $6. It's almost 2 gallons of gas. What? Are you having time flying because of the switch? Okay. Congruent. What does that mean? We've talked about it. We've said it so many times. What is it? Equal what? Equal amount, size, shape. So when you have, excuse me, when we deal with congruency, congruency is your fancy version of equality. Congruency is when you were just saying like equal size, equal measure. Things with equal value, I think I will use that word. Because a segment has a length, an angle has a degree. Surface area is a space. Volume is measurable. A number is a number. 7 equals 2, or 7 equals x. Okay? That's where that is. Doesn't mean that they're same value, because it's not measurable. Okay? That's where it gets a little weird. Just want to make sure you guys understand that. Now, when we get into congruency, we start to deal with what are called congruency statements. And congruency statements, and we kind of I showed you a little bit of it earlier without getting too involved with it, are very easy to work with. What congruency statements will do. Let's say, for example, we have a triangle.
So if I say I have triangle ABC and it's congruent to triangle XYZ, what do the ABs and Cs represent in the triangle? The angles, okay? The vertices. You guys ever heard that term before, the vertices? Okay. So if you have a triangle, then I call it, doesn't matter which one I call A, B, or C, just if I'm just drawing a quick picture. It just means I go in order of the letters. I can pick any spot to go, and just follow the letters. Right? Now, if this one's going to be congruent to X, Y, and Z, they have to have equal value, equal measurements. Again, I'm just labeling out my vertices. Now, what a congruency statement tells you is it gives you direct correspondence to which pieces are congruent to which piece. For example, if I say angle B, what letter has to match angle B on the other triangle? And why would you say that? They're corresponding, they're in the same position. Remember when we talked about corresponding angles? Parallel lines cut by transversal corresponding angles where the angles in the same position. It's kind of the same idea as you think about the terminology here. If you had parallel lines cut by a transversal, corresponding angles were congruent because they were in the same position. If I think about that word corresponding, the letter B matches the letter Y because they're the second letters. Same thing with A. A has to match with X, and then C would have to match with Z. Okay. Now, when you mark diagrams, we've been doing a little bit more of this. When you want to mark a diagram as far as something that's being congruent, we use what are called tick marks. You guys may remember using those? So if I say A with a single tick mark, how many tick marks do I put on X? Yeah, same thing. If I put 2 for B, 2 for Y, if I put 7 for C, I will put 7 for Z. How about I just do 3? They just match up. One thing that'll happen, today we're talking a lot about just triangles, and we'll have like some quadrilaterals on both sides. Sometimes they'll use 4 tick marks, but sometimes they might do this. Put a single one and then just put something like this in it. As long as they match, it's fine. Does that make sense? Yeah. You'll see the same pictures of it. So just a little heads up. So angles are very easy to look for. What about sides? How many letters do you need for a side of a triangle? Sides? 2. From point A to point B is a side, isn't it? Point B to point C is a side. C to A is a side. If you're just looking at it, and let's say you didn't even know this. Let's say you didn't know that, but you had these pictures. What corresponding side goes with AC? XC. Easy way to look at it, between A and C, there's 1 tick mark to 3 tick marks. What corresponds to that on the other one? And that's where this comes from. Oops. That's the idea here. You look for the correspondence between tick marks, or I had this guy back up here a minute ago. I look at the correspondence between the letters. Segment AB, 2 vertices in a row, those are the endpoints. That's your segment. Segment AB has to match which segment? First 2 letters. BC has to match YZ, second 2 letters. CA, ending, beginning. CX, ending, beginning. So with these congruency statements, grab this guy here real quick. With these things that are called congruency statements, you're very, very easy, or it's very easy to write out which angles are congruent and what sides are congruent. Just by the letters. Now, in a triangle without any extra segments in it, how many angle A's are there? Think about the picture we just had. How many different angle A's are there? Just one. Just angle A. Does it matter if it's BAC or CAB? Isn't that the same angle? So when that happens, you're allowed to use one letter. If this had a segment going, through there like that, I couldn't say angle A because there's three different ones. BAD, I'll call it DAC or CAB or BAC. There's other ways of doing it. If it's one vertex with one spot, one letter is okay. Otherwise, you have to use three. This comes with time. No big deal. But anyway, like you just did, angle A has to match up with angle what? B, C. The reason why I put these things out and I write them out is because eventually, like we've been doing, you'll have pictures and diagrams in algebra. That way you can see the direct correspondence to what matches with what. AB has to go with XY, good, good, good. BC, YZ, and CA, ZX. Can I say AC? If I say AC, what would have to match up? If I'm following the true of the letters, if I say AC, first last, isn't it? What would have to correspond to that? XC. You're not wrong that they are the same because it's the same thing forward and backwards. It's just when they have these things written out, you have to follow what they do. Does that make sense? It's kind of particular. Even though you're not wrong, it's just it's very hoity-toity, if you will. Fancy. It's like going to a really, really fancy restaurant with like 7 forks. That's so funny. Why are you laughing? So, do you want me to start doing sides? So if I write it with a Z, will you write it with an S? I'm just messing with you. Hey, at least you're awake.
Yeah, I'm not
Okay. All right. Take these letters, write me out a congruency statement. Take these letters, write me a congruency statement. Angles and sides. Please and thank you. We're running through a proof with it, but if you want to do that to show which one's matched to which, I guess. But what I mean by a congruency statement, I'm saying, what does angle J match up with? Okay. What is side IJ match with? That's what I mean. Just write the congruency statement. Yeah. So how many sides should you have? And how many angles should you have? 4, which means how many totals should you have? Que bueno para su clase de matemáticas, es muy importante. Sí. Con accente. Again, this should not be difficult. One thing that I know that you guys get lazy with, label. You can't just say H. What is H represented? It's an angle. Okay, angle H has to match up with angle L. Again, really, really easy. Lettering, just go in order. Do you have to put the bars above the letters? Those. And I know this seems tedious. It's a little bit of a busy work, to be honest with you, as we start through some of this. But the reason behind writing out congruency statements, as well as eventually we get to similarity towards the end of the semester, writing out the similarity statement, you'll be able to figure out what matches with what. And the easier, the more comfortable you are writing this out, the easier everything else becomes. Again, should be pretty decent. Which means we can math. Sorry, please. In the diagram, it says shape DEFG, and kill this one out here too, is congruent to S, P, Q, and R. Now, when it comes down to these things, do you need to draw everything? Probably not. But understanding what things match with what will allow you to, bless you, allow you to figure this out. Okay? So when you're looking at it, it tells you to figure out what the value of x is and then find the value of y. Well, if I'm looking at where those variables are located, I've got one at QR. What segment does QR have to match up with? FG. It's got to be FG. Don't believe the picture. Follow the congruency statement. Okay? Don't believe the pictures. Follow the statements. Especially if things aren't marked. Okay? That's why we do these statements, that way you can figure out what ones match up. So if that works, then you've got what? 2x minus 4 has to equal 12. What's your first step? Good. Add 4. Oh, you don't have to do this in terms of a proof. That's okay. But you're right. Now what? Then what do you get? Okay. Now, where's y located? What angles match it up with? Look at the letters. Follow your letters. QR. See where I'm going with that? You got to believe the letters. Don't believe the diagram. That's the point, because that diagram has so many different possibilities. You don't know which one's going to match up. Now back to angle Q. Which one does it have to match with the letters? F. It has to measure with F, or match with F. It is the third letter. It's the third letter. So I know that angle Q has to equal angle F. Well, Q, 6y plus x, is 68. But we just figured out what x was, didn't we? What was x? 8. So I know that it's 8. You should be able to look at that problem and give me what y is without really mathing too hard. About 10 or is 10? Approximately 10. No, that's like a time. It's 10-ish. 10-ish would be, well, if you Could be 10-ish. You're going to go play 10-ish. That's bad. Thank you. The answer is just 10, okay? Subtract 8 divided by 6. You should. That's the idea. Can you look at a congruency statement, figure it out? Hopefully, yes. Now's where things get interesting. Take out your progression sheet for a second. And I want to add this. I don't think we did this one the other day. I think the ones we have, we only did one. We did what? Yeah, the congruency switch. So as we go along, and we've kind of talked about this, there's certain things that you can take from a diagram. Certain things you can infer. Remember saying that term last week? Certain things you can take from a diagram, like vertical angles, linear pair, things like that. Well, what do you know about vertical angles? They're when the lines intersect, but more specifically, what about their values? Yeah, they're congruent. Vertical angles are always equal to each other. Remember, when you have vertical angles, you're talking about two lines that intersect. If I look at this one and this one, those two would always add to 180. This one plus this one would be 180, and these two would be 180. So you get the idea of vertical angles being congruent. So if I say angle ABC and XBY, this is one of the things you can infer from a diagram. You can say this, statement, reason. This might not be given to you. In fact, it probably will never be given to you. Vertical angles won't be given. Vertical angles is always going to be a statement that you're going to be allowed to do. You have a copy of it. Hey, if you need another copy, I'll get extras too. You guys lost yours. No progression sheet, squares. Okay. So one of the things that you can always be able to take from a diagram is that you can always say that vertical angles are congruent. So I could come up and, if I knew nothing else about this diagram, but I needed to come up with something to say in a proof, I could say that angle ABC is congruent to XYZ, or excuse me, XBC, XBY, and the reason being vertical angles are congruent. That's all you'd have to write. Put away your phone. Seriously, if you can't handle it, put it up in here. All right? Trust me, ladies and gentlemen, staying off phones is good for your brain. Okay? Now, obviously, there's a whole other set of vertical angles also. I could have said XBA, YBC. That's fine. It just really depends on what kind of a problem you're working with. But stating that the vertical angles are congruent is always going to be something you're allowed to do within a proof. Okay? It's one of those inference things that you can do. That's why I wanted to make sure you guys had that on your regression sheet, because do we take those away from you? Oh, they're there for help you. So if you're looking and you're staring at something, trying to figure out something to do, you know that's something you can do. Okay? So to go along with that, some of you guys are still finishing it out. I'll show you the example of what I was going to do with this. So as of right now, we've said that congruent figures are figures that are congruent that have all their corresponding parts that are the same. All the angles are congruent, all the sides are congruent. If you've got a triangle, there's 3 sets of each. If you have a quadrilateral, there's 4 sets. If you have an octagon, there's 8 sets each. So there's a whole bunch of stuff to pay on. Letters. Now, if I go back to look at something like this, and I want to see if these triangles are congruent. We know that congruent triangles have 3 congruent sides and 3 congruent angles. That's all we know right now. Eventually, we'll find out other ways of doing this. But if I'm looking here at my picture, how many angles do I have marked? There's two sets of angles that are marked. Okay. A and E, B and D. Those are the only two sets that are set up. To say that these two are in fact congruent, what can I infer from that diagram? What's that? What angles can I say that are congruent? What's that? Angles. Well, from the diagram, yes, we know that angle A is congruent to E, B is congruent to D, but I need the third angle. What am I missing? I can't just say C. A, B, C. Follow your letters. Hold on. I'm assuming you guys are looking at the vertical angles here, right? I hope. These two right here. Those are vertical angles. One of the things that you'll see a lot of times, you might want to put this back on the progression sheet. Go back to the progression sheet here. Oops. Think of a bow tie. Pictures like that will usually have vertical angles. Think of a bow tie. Okay, put a little diagram of a bow tie in there. Now I'll love to figure that out. It looks like a bow tie. A lot of times you get that. So if you back here, those two have to be the same. I can't say angle C because there's 4 different angle C's there, depending upon how you do the letters. So if I say angle ACB, what letter did I start that at? A. Is it going to be DCE or ECE? How many tick marks does A have? Yeah. Everybody see that? I don't know if you guys heard of it. The reason that I have to say angle ECB, because this one started with just 1 tick mark, went to the middle to 2 tick marks. You have to correspond it with the other letters. It's still the same angle, but the direction is important. The lettering has to match. That's where this is where the attention to detail really gets important. Okay? So again, we know that triangles have 3 congruent sides and 3 congruent angles. That's what we were putting in here. BCA, DCE, it's another way of writing that. Starting at B, 2 tick marks. C, where the vertical angle is, to A, the 1 tick mark. Those 2 guys are vertical, which means that they are. Again, nothing too crazy, nothing too difficult. Very straightforward. Oh. Just want the picture. What? She had the phone out, she's taking pictures of this, I went like that. Whatever. Here's a real easy thing. Let me talk about this. How many degrees are in a triangle? How many? 1/8, okay. So if I say this is triangle ABC, X, Y, and Z. If angle A is 65, angle C is 70, and I know that these triangles are congruent. If I know those 2 things, what can I say about angle X? Congruent to A, which makes it how much? What about y? What do you have to do? Math. Okay. 65 and 70 is how much? 135. Which makes the other side y how much? Okay. And this has to be here. Now, if you only knew these two angles, don't the other two angles have to be the same value? No matter what, because how many degrees are in a triangle? 180. Does that ever change? No. Well, can, but we're not going to worry about that. No, didn't I show you guys you can have more than 180 degrees? Yeah. Don't write this down. Sphere, right? You guys remember that? Oh, where you take, you start at the North Pole, you draw down the equator, so that your, well, you guys see it. That way, it's perpendicular to the North Pole. Those are longitudes along that, right? Longitudinally, they form a right angle. Don't all longitudes, are they all perpendicular to the equator? If I come across the equator, these are also perpendicular. So that is a triangle, but it's on a spherical plane. It's not a globe. How many degrees is 390 degrees? You said. So if you curve your plane, you have more degrees. Anyway, so what happens here is there's this thing called the third angle theorem. It's nothing more than this. If two angles, oh, here I have it right now. Third angle theorem basically states that if you've already got two sets of congruent angles between two triangles, the third angles have to also be. It makes a lot of sense when you start putting numerical values. If you throw numbers in there, it's super fast. All you need to remember is if you've got two, the third has to follow. It has to. Because of how many degrees are in a triangle. Right? What? Did you cause a lot of trouble? Did you just go cross-eyed staring at your own face? All right, seriously, you're like, hey, how about this? You can sleep in tomorrow. No, because then we have to go. All right. Who's sleeping? It says you're open right here. Because there's no eyes in the back of your head. Or yours. Anyway, we won't have time for that today. So let's see, what do we got? A couple minutes? Go back to this one real quick. Take a minute. Figure these two out, please. And thank you. So when you're looking at these problems here, if I'm looking at angle I, what does it have to match up with? D. It's also kind of a dead giveaway when there's only one angle measure given to you. All right? And same thing with the side measure. I mean, it's kind of tough. Remember, sides don't equal degrees and angles don't equal feet. Did I say eat feet? Equal, whatever. Potato, potato. What do you do first? And you get 56, very good. And then you divide by and get helps if I can math better and get math should be pretty simple today. We didn't have time to get to it. We'll do those on Thursday. Textbook, make sure you write that down, screenshot it ASAP so you don't lose your internet. We'll go through a little bit of this on Thursday and talk back about some congruency statements and whatnots and fun.